you don't pay attention to exactly what L'Hopital's rule says. So let's look at this example. Let's say that you wanted to find the limit as x goes to infinity of x plus sine x all over x. Okay? So when you look at this, I see a ratio of two functions, and if you look at the top, okay, x plus sine x, so what's the limit of that as x goes to infinity? It's infinity, right? Because, okay, x is going to infinity. Now sine x is always between -1 and 1. So if you take something that's going off to infinity and then add something that's always between -1 and 1, the sum will go to infinity. All right? And the denominator, x, is also going to infinity. So this is infinity over infinity, and then you say, great, let's use L'Hopital's rule. So let's see what happens if you use L'Hopital's rule. So this is equal to, by L'Hopital's rule, and I put like this to indicate I'm using L'Hopital's rule, the limit as x goes to infinity of, well, the derivative of the top over the derivative of the bottom. And that's easy. The derivative of the top is 1 plus cosine x, and then the derivative of the bottom is 1. Now what's the limit as x goes to infinity? So this is 1 plus cosine x, right? What's the limit as x goes to infinity? It doesn't exist, right? The limit doesn't exist because this function, 1 plus cosine x, is just, it's just a wave and then shifted up by 1, right? So there's no limit because as x goes up to infinity, the y values don't approach any particular number. So the limit here does not exist. And you might be tempted to say, well, the limit doesn't exist. The original limit doesn't exist by L'Hopital's rule. And that's actually not correct. It turns out that the original limit does exist. And let's see what that is. So let me just say something that's not correct. So what would be wrong is to say that this limit does not exist. The correct statement is well, let's think about how we can do this. We can split up this fraction, right? So it's equal to the limit as x goes to infinity of x over x plus sine x over x. Right? All I did was I just split up the fraction, and then this is equal to the limit as x goes to infinity of x over x is 1, and then you have sine x over x, and now I want to find the limit of sine x over x. I have 1 plus the limit. I can move the limit inside. That's a property of limits. And what's this limit? As x goes to infinity, the limit is 0, right? By the squeeze theorem. So this is 1 plus 0, which is 1. So the correct answer is 1. And by the way, let's review, just in case you're not sure, how you know that this limit, how do we get from here to 0? It's because, so I'll just draw a little cloud here. It's because sine x is always between -1 and 1. And so therefore, when you divide by x, and since x is positive, the inequality signs don't change, like this. And when you have this function, sine x over x, in between two other functions, and if these two approach the same limit, then the inside also has to approach that limit. And since limit as x goes to infinity of -1 over x is 0, and the other limit, 1 over x is 0. So since these two ends approach 0, then by the squeeze theorem, or sandwich theorem, the middle term has to approach 0. Okay, that's a very typical squeeze theorem or sandwich theorem example. So anyway, the correct answer is 1. That's the answer to the original question. So what happened with L'Hopital's rule, right? Why is it wrong to say that the limit doesn't exist? I mean, we didn't make any calculus mistakes with the derivative, and it's true that when you took the second limit, it doesn't exist. So what goes wrong? Well, what went wrong is you have to pay attention to exactly what L'Hopital's rule says. L'Hopital's rule says that if you have, I mean, there's like different versions of it, but the one we had was the infinity over infinity version. So it was, you know, if you have some limit of f of x over g of x, and you get infinity over infinity, okay. So if f of x approaches infinity and g of x approaches infinity, and, okay, so how do I write this in a very precise way? So let's say that you have something like this, limit if the limit as x goes to a of f of x is infinity, or plus or minus infinity, and the limit of g of x as x goes to a is also plus or minus infinity, and the limit as x goes to a of f prime of x over g prime of x exists, right? And let's say it's equal to L, okay, then the original limit equals that limit, L. Okay, that's what L'Hopital's rule says. So what happened here was, okay, our f of x was x plus sine x, our g of x was x, right? But when we did f prime of x over g prime of x and did the limit, that limit didn't exist, right? And when you read L'Hopital's rule carefully, it says, okay, if, you know, the limit of the top and bottom is plus or minus infinity, that's what happened, and this limit exists. Oh, okay, if it exists, then they're equal. So in other words, if we had found that the limit here, this limit, let's say we found that the limit was like 7, okay, then the original limit would have been 7, right? But if, and in this case we found that this second limit doesn't exist, then we can't actually say anything about the original limit. L'Hopital's rule doesn't tell you what happens if this limit of f prime over g prime doesn't exist. Okay, so if, you know, the limit of f prime over g prime doesn't exist, then you can't, then L'Hopital's rule doesn't apply, it doesn't say anything, and you have to do something else. Right, you have to try a different method. And when you do the different method, in this example, you do get the correct answer, which is 1. Okay, so this is something that's worth pointing out. I don't see an example like this in the Stewart Calculus book, and also there are some websites like this Paul's Online Notes, section 4.10. You know, it's like a widely used reference, and I guess Paul says L'Hopital's rule says that, yeah, he doesn't say the correct thing. The statement of L'Hopital's rule on his website is not right. It just says that if you have something like infinity over infinity, then you can just say that the original limit is the limit of f prime over g prime. That's not correct. I should contact this person and tell him that he needs to change the sentence. Of course, you know, when he's writing this up, he's probably just being very, vague, and he's not going to run into examples like this, um, right? So that's probably the issue. But no, the statement that is on Paul's online notes website is not correct, and this example proves, right, that this limit that we're trying to find does not actually match the limit of f prime over g prime, because one of them is 1 and the other one doesn't exist. Okay, so just something to be mindful of when you're applying these theorems. It's really important to know exactly what the theorem says, because if you don't, then you might be doing the wrong thing and getting the wrong answer.